Today, we're diving into a commercial proposal that's pretty wild. It suggests using a super high-tech solution, colloidal silver, to keep our juices and beverages fresh. So we're talking about microscopic silver particles as a weapon against spoilage. Let's unpack what that really means.
It's something you probably don't even think about. You grab a juice, and it just lasts. But behind the scenes, there's this invisible war going on inside that carton, a constant scientific battle to keep it from going bad. So what's the science behind that? And is it all about to change?
For the companies that make these drinks, this isn't a small thing. It is a massive daily challenge. Inside places just like this, millions of liters of product have to be protected from contamination. It's a constant headache where just one tiny slip-up can ruin an entire batch.
So what is this invisible enemy they're fighting? Let's take a closer look at what this proposal is really designed to defeat.
The proposal basically maps out all the danger zones. It all starts with the raw fruit itself, right? Which can carry all sorts of stuff: yeast, molds, bacteria. From there, the risk moves right into the tanks and pipes, where this slimy gunk called biofilm can start to grow. And get this, even after everything's been pasteurized, it can get contaminated again at the very last second during bottling. Every single step is a potential point of failure that can lead to spoilage and a whole lot of waste.
So, to combat these invisible enemies, a company called Si14 Pharma is pitching a solution that sounds like it's straight out of science fiction.
And here it is. This is the stuff at the center of it all. It's a concentrate they call colloidal silver, and it's designed to be the one tool a company needs to handle all those microbial risks we just saw.
So what in the world is colloidal silver? Well, imagine incredibly tiny particles of 99.99% pure silver just floating around in water. We're talking unbelievably small, around 15 nanometers on average. You can think of them like a microscopic security force, just waiting to take on any bacteria or mold that shows up. The proposal really highlights that tiny size and purity as the keys to making it work.
Okay, but how would a factory actually use this stuff? Well, the proposal outlines a two-pronged strategy. Basically, two different ways to attack the problem.
And this is really the core of their whole idea. On one hand, you've got the first approach, using the silver solution as a disinfectant to clean all the equipment, the tanks, the bottling lines, the whole shebang. But then, on the other hand, you have the second and much more, radical approach, adding it directly into the juice as an ingredient to protect it from the inside out.
First up, cleaning the factory. The process seems pretty straightforward. You mix a little bit of the concentrate with a lot of water. Then you can either spray everything down or use what's called a dry fog generator, which fills the room with a super fine mist to get into every single nook and cranny. You just do this every few days to keep the whole place sterile.
Method 2 is way more direct. Here, a very tiny, precise dose, just 1 milliliter for every 10 liters of beverage, is added right into the juice itself. This happens at the very end of the line, just before the cap goes on. Now, the document is careful to point out this would only be done after it passes rigorous tests by the company's own quality control team.
Of course, making big claims is one thing, but does the proposal have any proof? Let's take a look at the scientific evidence they've included to back all this up.
I mean, that's the bottom line, isn't it? Does it actually kill the germs it's supposed to?
And boom, here is their main piece of visual evidence. On the left, you see a control sample in a petri dish that's just crawling with bacteria. But on the right, that's a sample from the same source, only this time it was treated with their colloidal silver. The document says this picture was taken after just 40 minutes, and the difference is pretty stark. And they back that picture up with some really specific numbers from studies they reference. The proposal claims 100% suppression of some tough antibiotic-resistant bacteria. For fungi, it claims a reduction of over 99.9% in just 40 minutes, with complete elimination after 2 hours. Those are some very, very bold claims about its power.
So if it works like they say it does, the next big question is always money. What does it cost? Let's dig into the economic argument the proposal is making.
The proposal breaks it down like this. First, the cost. If a company uses it as a direct additive in the juice, they calculate it adds about 2.90 Russian rubles per liter.
But what do you get for that extra cost? Well, the first big benefit they claim is on the factory floor. When you use it as a disinfectant, the proposal says you'll see a 99.9% drop in the bacterial load on all your surfaces. And that cleaning power, they argue, turns into real savings.
The document makes the case that a company could slash its spending on traditional chemical disinfectants by as much as 50%. That's a huge number.
So this is their core pitch. The argument is that, yeah, it adds a tiny cost to each liter, but that's easily offset by the return. You get a longer shelf life, you waste less product, and you save a ton of money on cleaning chemicals. It's that classic, spend a little now to save a lot later argument.
All of this really brings us to a much bigger question about where all of this food preservation technology is actually heading.
This quote right from the proposal pretty much sums up their entire sales pitch. They position it as natural protection without chemistry, promising a longer shelf life and lower costs. It's a really interesting choice of words, isn't it? Framing this incredibly advanced nanotechnology as some kind of natural solution.
And that leaves us with a huge question to think about. Proposals like this one are pushing nanotechnology out of the laboratory and directly into our food supply chain. So, as we weigh the potential benefits, like less waste, against the idea of consuming silver nanoparticles, you have to ask yourself, is this the future of our food?